Welcome to Math 103, Topics in Math for the Liberal Arts, and to the first video of the first chapter on the mathematics of voting. Voting occurs in many contexts in real life, not just on Election Day. Certainly we vote for political candidates on Election Day, but, for example, whenever an organization needs to select its leadership, or an award committee needs to decide who the recipient of the award will be, or a group of friends need to agree on where to go for dinner, on some level, a process of voting is taking place. In any of these contexts, the fundamental question is, when an election is held, possibly with more than two candidates, how do we determine the winner? Another way to phrase this is, when an election is held and each individual's wishes are expressed on a ballot, how do we determine which candidate best reflects the overall wishes of the electorate as a whole? The common response is simply, whichever candidate gets the most votes is the winner of the election. That seems reasonable enough, and it is when there are only two candidates. For example, if you had an election with 50 voters, so 27 voters here plus 23 voters there, 50 voters total, and the candidates are Pat and Sam, who will be two of our recurring characters through the course. Well, Pat had more votes than Sam, and there were only two candidates. So what doubt could there be? Pat seems to win this election unambiguously. When there are more than two candidates, the situation really is more complicated and not so obvious. So we continue to think about 50 voters. Now there are three candidates, Pat, Sam, and Alex. Okay, so Alex has entered the picture and drawn 12 votes. Sam has lost a few votes down to 20. Pat has lost a few votes down to 18. Pat has lost quite a few votes, actually. And in the end, well, which candidate best represents the will of the voters? That's always the fundamental question. It's not quite so obvious here. You could say that it's Sam, because Sam has more votes than any individual opponent. But we'll see when we go on that the matter is more complicated. So in order to gauge the voters' wishes more effectively, we can ask each voter to fill out a preference ballot. That is a ranking of all the candidates with no ties allowed. So we are accustomed in most elections to just voting for our first choice, and that's all the information we give. That's all the information that we're asked for. In a preference ballot, there's a first choice that you write down. You also write down your second choice and your third choice. We're going to make the rule in this chapter that however many candidates there are, each voter must rank all the candidates in order without any ties. But what if I just want Sam to win, and Pat and Alex really are tied in my mind? Well, just for simplicity, we are ruling out ties for the purpose of this discussion. A more advanced course would deal with ties on a preference ballot. Now, this kind of ballot is actually used in a number of elections. For example, in certain mayoral elections in American cities, and in the Australian House of Representatives. There is a small but growing movement to use such ballots in national-level elections in the United States. So let's look more closely at what this means. Of the 18 voters whose first choice is Pat, some will fill out their preference ballots as Pat, Sam, Alex. Okay. Others will fill it out as Pat, Alex, Sam. So that means that every one of the 50 voters is going to fill out a preference ballot in this way, and after doing so, they will all put their ballots together, and someone will assemble all the information into a preference table. What does that mean? It's a gadget like this right here. It is a table that records all the information. This column means that there are 4 voters who voted for Pat in first choice, Sam second, Alex third. 14 voters voted instead for Pat, Alex, Sam. So notice that we said earlier that 18 voters wanted Pat to win the election. But now, by asking every voter to fill out a preference ballot, we actually get more refined information. The overwhelming majority of Pat supporters, of Pat's 18 supporters, most of them far prefer Alex as second choice to Sam as second choice. Okay. How about Sam supporters? Well, there were 5 plus 15 makes 20 total Sam supporters, but they broke down into 2 groups in different ways. And similarly, 12 voters total voted for Alex, but those 12 break down in this way. Again, the question is always, which candidate best reflects the voters' wishes overall? Well, here's our preference table again. Okay. So how do we answer this question? Well, we apply a voting method to the preference table to determine the winner. What does that mean? A voting method is a specific rule that is previously agreed upon prior to the election. Okay. That rule takes the information in the preference table as input, it performs some computation on it, and then it gives the winner of the election as output. That is what we mean by a voting method. It takes a preference table as input, tells us the winner as output. There are many different voting methods. Each one is based on a particular approach to answering the fundamental question, which candidate best reflects the voters' wishes overall? Now, look at this preference table and look at what a mess of information this preference table is. It's quite a lot of information, and this is with only 3 candidates. It gets much worse with 4 candidates. There is no clear intuition from staring at this collection of information that would make everyone say, well, obviously so-and-so is the winner. Now, there are voting methods that will crunch all of this information and conclude that Pat is the winner. There are different voting methods that will crunch all the information in this preference table and conclude that Sam is the winner. There are still other voting methods that crunch all the information in the table and conclude that Alex is the winner. So what does this tell us? What's the conclusion? The conclusion is that choosing which voting method to use has consequences. When you hold an election, you have to decide in advance which voting method you're going to use, because using different methods might result in different candidates winning. So let's sum up. Throughout this chapter, we study elections involving several candidates. In this framework, instead of having each voter vote for one candidate, each voter will instead rank all the candidates on a preference ballot with no ties allowed. Okay? There are other ways of setting this up that do allow ties. The way we're going to discuss it, there are no ties allowed. Okay, then, all preference ballots are assembled into a single preference table. And finally, some rule previously agreed upon, some rule called a voting method, is applied to the preference table to determine the winner of the election. Now you may ask, why is this chapter in a course in mathematics? Well, mathematics does have a role to play. First, by defining each voting method in a precise way. Okay, so we're going to need to define each method and apply it to particular elections and find the winners. Furthermore, we're going to use mathematics to formulate precise definitions of when an election outcome is quote-unquote fair or unfair based on certain intuitions we have about fairness. Now wait a minute, I thought math wasn't about things like fairness. I thought math was just about math. But in fact, math can be used to take intuitions that we have about what constitutes a fair outcome or an unfair outcome and make those intuitions precise. Before you go on to the next video, look closely at the following preference table. With 100 voters, right, so 35 voters plus 28 voters plus 20 voters plus 17 voters, that's 100 voters total, okay? And 3 candidates, Coleman, Humphrey, and Ventura. This example is based on the 1998 Minnesota gubernatorial election. That is not where they elect the biggest goober in the state. It is where they elect the governor of the state. Okay, and please answer the questions below. So based on your intuition, which candidate do you think best reflects the voters' wishes overall? Okay, I'm just asking here for your intuition. In what sense did Ventura receive most of the first place votes, and in what sense did Ventura not receive most of the first place votes?